Hello, my beautiful computer science students. Welcome to another AP CSA lesson where I, Goldie, take you through Unit 2 using objects. Today's lesson is Lesson 8, the math class, and this is going to be our last lesson in Unit 2. Our objectives, we're going to talk a little bit about static methods today. Not how to write them, but just using the math methods themselves because they are static. We'll talk a little bit in the beginning about what those are, and then just evaluate expressions that use those methods. Okay, so let's go ahead and get right into it. So what is the math class? Okay, the math class is again another object class that's part of the lang package that automatically gets imported into every Java program. Now, when I say it's an object class, you actually don't create objects with this class. This class has a bunch of static methods, okay? Which means that instead of using an object to call the method, we use the class name before the dot notation. Static methods are methods we want to use segments of code that we basically want to use and call on, but we don't need an object to do them. So what you're going to see when we call on these methods that we're going to talk about, it's going to start with math, capital M, and then a dot, and then the method name. Okay. Usually before the dot notation, we would have a reference to an object, but we're not going to create objects with our math class. They are all static methods, so we use the class name. Okay. We'll actually create our own static methods and talk more about them in Unit 5, but right now here's a little introduction into actually using them. There are many math methods. If you look online and type in math methods Java, and you'll get a whole list of all math methods that you can use. There's 5 though that are specific to the AP exam, and those are going to be the 5 that we'll focus on in this lesson, but just know there's tons of methods that you can use, and some you might even find useful in your programs that you write later on in this course, so just know that they're out there. Here are the 5 that we are going to use in this class. So the math methods, as they're written right there on the screen, that's how they'll appear in the Java quick reference. And the reason they appear like this, what you'll see first, excuse me, let me get my little pen out. What you'll see first is the return type, and then you'll see the method name, and then you'll see what parameter it accepts. Okay, so this is the ABS method. It accepts an integer and it returns an integer. ABS stands for absolute value. So it returns the absolute value of an integer. So here's an example. If I have this segment of code, math.abs parentheses -7, it's going to return the absolute value of -7 as an integer. So this would return a 7. Okay. You can also have ABS at returning a double and accepting a double. So this is an overloaded method, ABS. If it accepts a double, it returns a double. Okay, so it just returns the absolute value of a double value. So here's an example. If you pass it a double, it knows that you want the absolute value of that double. Now the absolute value of a positive number is just that number itself. Okay, so that's 2 of them is your absolute value. Whether it's an integer or a double, it returns the absolute value of either. Next is the POW. Okay. POW, and you can see there's only one method called POW. It accepts two parameters, double and a double. Okay, so 2 doubles. Remember, you can pass it to integers; they just get promoted to a double. So the POW method returns the value of the first parameter raised to the power of the second parameter. So that's why I called this base and this exponent. The first parameter is your base. The second parameter is your exponent. So if you have math.pow 4.5, 2, what that is saying is take the value 4.5, that's your base, and raise it to the power of 2. So this is how we handle exponents in Java. We said, I told you before, there's no caret symbol in Java at all. In order to get an exponent, you have to use the .pow. So 4.2 to the second power is going to be 20.25. Okay. And again, you can pass it integers. It'll always return a double. Okay? Even if you pass it to integers, it'll still return a double, but you are able to find the power of two integers. The next one, SQRT, stands for square root. You pass it a double, it returns a double. Even if you pass it an integer, it'll still return a double. So the square root of 25 is 5, and it's going to return 5.0 because it returns a double. Okay. The last one is random. Random accepts nothing in parentheses. Right? It is a 0 parameter list, and it returns a double value greater than or equal to 0 and less than 1.0. Okay? And that's how it's used. We're going to talk about random towards the end of the lesson a little bit more after we work through a couple of expression examples first. Okay? But we're going to expand on exactly what the dot random does here in a moment. But those are your math methods. Those are the 5 we're going to be focusing on. Okay, let's take a look at 3 examples of kind of these working, okay? So if I have int x equals 9, y equals 2, and then I want to do math.abs y minus x, okay? So in parentheses, it's going to evaluate that expression first. So y minus x is 2 minus 9. 2 minus 9 is negative 7. Once that expression is evaluated, then that negative 7 is passed to the math.abs, to the math.abs method. So the absolute value of negative 7 is positive 7, and even though it's passed an integer, it's returned as an integer, but it's stored in a double. Okay. Now it could have easily been stored in an integer because the .abs, if you pass it an int, it returns an int. But here in this example, I have it as a double, and it's going to print off like it's a double, 7.0. Okay. So just pay attention to those little nuances. I don't think the AP exam gets that picky when it comes to printing off 7 versus 7.0, but just in case, I want to make sure you know the difference there. Okay. The next one, x is 9, y is 2. If I do pow, x comma y, that's 9 to the second power. And even though, again, those are 2 integers, the pow returns a double, stored in a double, it gets printed off as an 81.0. Okay, 9 to the second is 81. Okay. And the last one, you can use these math methods as part of a larger expression. So if I have math.square root x times y, okay, and again, kind of whatever complex expression you have, your math method will get evaluated. The square root of 9, it's a double. Remember, it returns a double, so that's a 3.0. 3.0 times 2 is 6.0, and that prints off answer 3 as a 6.0. Okay. So you use these math methods just in any expression, okay? Just like you would see in an algebra class. Now let's switch to random numbers, because this is probably going to be the little new piece here. Math.random produces a random decimal between 0 and 1. If I were to have this code segment and I printed off what that decimal was, what would print to the console would be this long decimal, okay? Something that looks like this. It would cut off, I forget at what value it cuts off, how many decimal points, but that's what would appear, okay, if you just did the math.random. And random numbers in our program are very useful. We'll see a lot of different situations where we need to produce a random number, but often we don't care about that random decimal, okay? We want some sort of random integer to appear. And using some smart math, we can actually transform this random decimal into a random integer. And that's what the next few examples are going to take us through, is how we can use some smart math to get a random number that we want, right? Like if I wanted a random number between 50 and 100, right? My program needs a random number between 50 and 100. How can I use math.random to get a random number between 50 and 100? Let's see it. Okay. So all of these code segments, okay, are going to give us some sort of range of numbers. So we're going to talk about what that is. So this first one starts off as math.random times 10. Okay, so that's the expression I have, math.random times 10. What are the possible numbers that are printed off with math.random times 10? Well, remember the smallest and the largest decimal with math.random is from a 0 up to 0.9999999, right? So if I have the smallest and the largest possible number, and I multiply each of those times 10, what I get is 0 times 10 is still just 0, or a really small decimal. And then that 0.999999 times 10 is 9.999, right? So the possible numbers printed when I multiply by 10 is going to be any decimal value between 0.0 and up to 10, okay? Because it goes to 9.99999. Okay. So now I'm getting a range of numbers, any decimal value between there. What if I did it times 100? Okay, so times 100 here, again, takes the smallest possible value and the largest possible value, times 100, each of those boundaries, and now I have any decimal value between 0 and up to 100, but not including 100 because it's 99.99999. Okay. So by multiplying, in those first two examples, by multiplying by 10 or by 100 or anything, you can get a range of values, right? So multiplying by 10 gave me a range between 0 and 10. Multiplying by 100 gave me a range between 0 and 100. So if I multiplied by 50, right, what would I get? I would get any decimal value between 0 and up to 50. Okay? So that's what that multiplier does. It gives you a range of values. Okay? In the next piece, we're going to take that logic, okay, knowing that math.random times 10 gives us a value between 0 and 10, and we're going to typecast it. Okay, so you see we get the math.random times 10, that happens first because that's in parentheses, and then the typecast of an int happens. Okay, so again, we get smallest times 10, largest times 10, but now we cut off the decimals because we are typecasting a double into an int, which truncates it. Okay, so we're chopping off the decimals. Okay, so that's why the smallest value is going to be a 0, and the largest value now is going to be a 9. Okay, so it's any integer value between 0 and 9. So same thing with the math.random times 100. Okay, if I go up here, remember math.random times 100 gave me these two values. And now when I typecast it here, I'm going to chop off those decimals. Okay, so I get between 0 and 99. So any integer value between 0 and 99. Okay. So with those two, we're slowly fitting the pieces together. And by the way, this will probably be changing your notes, but instead of decimal, sorry, I had a little typo. This should be rand number because this is my rand number. If you're using my notes, this is going to be changed, but it should print off rand number for each of those. Excuse me. So the next one, okay, we're adding on to it. So we have math.random times 10. We're going to truncate it. And then the last step, we're going to add a value to it. Okay, so remember parentheses first, math.random times 10, and then the typecast happens. Okay, order of operations, the typecast is going to happen first, and then the +1 happens last. So remember the int math.random times 10, this is where we're at. So what will adding +1 do to the smallest and largest value? Okay, it'll take 0 + 1 and 9 + 1, and now that becomes my smallest and largest value. So this segment of code is going to print off any integer value between 1 and 10. Okay. Same thing with the times 100, but now I'm adding a +8. So here was my times 100, and then truncating was 0 through 99. If I add 8 to each of those boundaries, so the smallest boundary and the largest boundary, 0 + 8 is 8, 99 + 8 is 107. So this code segment will give me any integer value between 9 and 107. Okay. So you see that? Now all of a sudden I'm able to get an integer value between two values that I want. Okay. And that's the little code segment that we use when we want a random integer. So here's kind of I call it a formula, but it's not really a formula. It's just a code segment that you're going to use. Int rand number, whatever your integer random number you want, is going to be that math.random times your range. You're going to truncate it, typecast it, and then add your starting value. Okay. So range represents the number of values between your two endpoints that you want. And with your range, you have to think about if you want the endpoint included too. So we're going to see an example of that here in a moment. But you've got to think of if you want your endpoint included for that range. Starting value represents the first integer number you want the random number to potentially be. So here's our last two examples here. So the first one, write code to generate a random number between 15 and 35. Okay. Now, when you think of 15 to 35, you just got to know two numbers. What's your starting value? Okay, well, it's 15. And then what's your range? Between 15 and 35, you might immediately want to say the range is 20. Okay. But you got to be careful with your range. Okay. Do you want the 35 included? Okay. If you want the 35 included, your range is actually 21. Okay. And it's a little confusing because of the way we count. But if you're including 15 and 35 in the numbers you want to generate, that's 21 numbers. You can count them yourself to know I'm right. It's 21 numbers. If you don't want the 35 included, it's 20 numbers. If you don't want the 15 included, it's 19 numbers. Okay, so pay attention to what the directions are asking. If they say inclusive, that means they want both endpoints included. If they say exclusive, they want both endpoints excluded. Okay, so just kind of remember that. Inclusive means include the endpoints. Exclusive means exclude the endpoints. Okay, here, the wording implies that we want the endpoints included. So 21 values, there is the range from 15 up to and including 35. Okay, 21 values. And our starting value is 15. So using, again, that kind of formula there, we would do math.random times 21, typecast plus 15. Okay. Number two is kind of a situation you'll encounter more when you're writing your programs. If we wanted to write code that simulates rolling two dice and calculating the sum. So you know 2 dice has the values from 1 to 6. Okay? There's six digits on a dice, essentially, right? 6 values on each dice. So you're rolling 2 of them. So the possible sums go from 2 to 12. Okay, right? Because the lowest 2 numbers are 1s, which when you calculate the sum is a 2. The highest 2 are going to be 6s, and 6 plus 6 is 12. And then you have a range of them all in there. Okay, so you might be saying, okay, 2 to 12, that is 11 possible sums, right? So your range would be 11, and then you would add 2 because that's your starting value, right? But you have to be careful here, okay? The probability of getting this all the same sum is not the same, right? So the probability of getting a sum of 2 is not the same as getting a sum of 7, right? Because the only way you can get a sum of 2 when you roll 2 dice is to roll 2 ones. But to get a sum of 7, you could roll a 1 and a 6, or a 2 and a 5, a 3 and a 4, etc. So the probability of getting those sums is different. And when you write a program, you want to preserve probabilities. Okay? Here, over in number 1, we didn't talk about probabilities because we wanted each of those numbers to have an equal chance of being chosen. Okay? In problem number 2, the same chance of choosing a 2 is not the same as choosing a sum of 7. Okay? So we have to preserve probabilities when there's a different chance of it being chosen, essentially. How do we do that? This is the way we do that, where we actually have 2 dice and use math.random twice. So times 6, because there's 6 values on a dice, and then plus 1. times 6 plus 1. So those both, when you roll a single dice, the probability of getting a 1 through a 6 is the same on each of them. Okay, so you're rolling 2 dice, simulating rolling 2 dice, and then the sum, to calculate that random sum, you just add those 2 random numbers together, and you're going to have a random sum. Okay. So when you write programs like simulating something, pay attention to those probabilities. Okay, and you can still use the math.random. Okay, that's how we get the random numbers, but just make sure that you're doing it in a way that preserves those probabilities. Okay, thank you so much for watching. That wraps up our lesson 8 on the math class. I appreciate you guys following along, and I will see you next time.